This is 3.3a notes, measures of dispersion. Okay, so just like measures of central tendency, we're going to start with the title, measures of dispersion. So measures, these are different ways to measure dispersion. Okay, so hopefully you know dispersion is how spread out things are. Okay, so we're going to talk about the different ways that we can measure how spread out data is. Okay, there's a couple of them that are things that are real, but we're not going to use them very much, so you will learn about them, and you'll be responsible for them for this unit. After this unit, we're not going to use them very often, and that is range and deviation from the mean. Okay, so you'd want to know them, be able to recognize them. You probably already know range, actually. So the range, there's no fancy symbol for this one. Okay, that's kind of how you can tell when there's something that's popular and not used a lot in stats or not, is if there's a fancy symbol for it. So the range is the high minus low. No fancy symbol. You just take the big number, subtract the small number. Okay, so for example 1, we take the biggest number. Notice these are already arranged for you. They're not always. Pay attention to what you're doing. 8 minus 3, which is 5. And so my range is 5. Okay, that's the easiest one. Very simple. Big number minus small number. And it's just telling you what is the distance from the smallest number to the biggest number. Okay, so that is a measure of dispersion. It's actually one that's used in math classes, but in real life, not actually used that often. Okay, because basically it's too simple. We're not really ever interested in what's the distance from the smallest to biggest number. We want to know more average values between every number. Okay, that's where deviation from the mean comes from. Okay, so this one isn't quite used as much. Well, I guess this is used, but we may take it one step further, basically. Okay, so this is the distance between each data value and the mean. Okay, remember that we have two symbols for the mean. This is the sample mean. This one is population mean. X bar, sample mean. Mu, population mean. So that's just a reminder of those. Okay, this one doesn't have a fancy thing either, but we are going to use this idea when we talk about variance and standard deviation, because it's going to take this one step further. So the deviation from the mean is the data point x minus the mean, or x minus the mean. Notice it's actually the same formula. It's just which type of mean are we talking about. Okay, so we take each value and subtract the mean. Okay, that means we have to find a mean, first of all. I used the wrong color. I'm just going to fix this real quick in the correct color for my own sake, so I remember where I'm at, so give me a sec. Okay, so I gotta find my mean. Okay, we're assuming this is a sample, which, by the way, if they don't tell you what it is, assume it's a sample. Add them all up, divide by how many there are. Hopefully you know how to find a mean by now. So add them all up first, and I get 25. Divide by how many there are. It's 5. Wait, is that correct? 14, 19. Yeah, okay. And I get 5. My mean is 5. Okay, so now I'm going to make a table because we got to find for each data point the deviation from the mean. So 3, 3, 5, 6, and 8. Okay, so I'm going to take the data point, subtract the mean from each one. So I get -2, -2, 0, 1, and 3. Okay. So this right here are our deviations. So this is the first two numbers are 2 below. The middle number is exactly the same as the mean. Then we have 1 above, 3 above. Okay, and you can know you're right because if you did the mean correctly, these deviations should always add up to 0. So -4 plus 4 makes 0. Okay, and that's kind of why we have to do something with this, right? We want to be able to find the average distance in some way, but if you add these up and it always equals 0, it's not going to quite work the way we want. Okay, so we have first the mean absolute deviation. Once again, this is one way to deal with this. It doesn't have a fancy symbol because it's not used super often, but you do need to know it for this chapter. Okay, the absolute deviation is the sum of the absolute value of the deviations divided by how many there are. Okay, so notice, I guess I can write in the same formula with the population. So notice absolute means absolute value. Deviation is the deviations from the mean, which we just talked about. Okay, so I have the same numbers, so I know my deviations already. So I found my mean to be 5 from the problem before. My deviations were -2, -2, 0, 1, and 3. Okay, so what I do is I take the absolute value of each one of these. So remember what absolute value does is it makes it positive. So if it's positive, it stays positive. If it's negative, it becomes positive. Okay, so I just take the absolute value and then I add them all up, and divide by how many there are, which is still 5. Okay, so I end up with 4, 5, 8 divided by 5, which is 1.6. My deviations, my mean absolute deviation is 1.6. Okay, so we take the absolute value of each one, add them up, divide by how many there are. Next, we have a different way. Okay, so taking the absolute value, that's one way to deal with these deviations to make them not add up to 0. The other way is the variance, and that is the most common used one. So this is one you really are going to need to know because we're going to do this all the time. Okay, so we take the squared deviations. Now we're going to square them. And we actually have two different formulas. One for sample variance, s squared, that's the variable. Notice you know you're going to use it a lot because it has a fancy variable now. So that's the sample variance, s squared, and its formula is dealing with sample data, so x minus x bar squared, the sum of the squared deviations divided by n minus 1. Okay, the n minus 1, if you notice, is different. It's how many there are minus 1. This is called a correction factor. It is a correction factor because of variability. If you remember, variability says if you take different samples, you're going to get different results. So we need to take into account that our sample might not be perfect. So we have this correction factor. We take n minus 1. Basically, we don't divide by such a big number. We're assuming a larger variance just in case there is. Okay. And then you have the other type of variance, which is sigma squared. This is a lowercase sigma. It looks like an O with a line on top. Lowercase sigma squared. And that is the symbol for population variance. Okay, population variance is sigma squared. And its formula is the sum of x minus mu, the deviations of the population values squared, divided by n. Okay, since we're using the whole population, we don't need the correction factor. So notice, you got to really understand this. The sample variance has a slightly different formula than any other thing we deal with, right? We divide by n a lot for mean absolute deviation, for population variance, but we divide by n minus 1 for that correction factor. That's something you definitely need to remember. Okay, so setting up my table again. This time we're going to square each deviation. Okay, you're going to want to know how to set it up. I'm not going to write the mean again. The mean was 5, right? So -2, -2, 0, 1, and 3. Then we square each number. A negative times a negative, don't forget, is a positive. So all of those negatives go away. Okay, so this is for sample. All right, don't forget that is s squared. That's the symbol for it. S squared is sample variance. Okay, so I just add them up. Divide by how many there are, -1. So I end up with 4.5. So I have a sample variance of 4.5. Okay, so that's assuming they're samples. On the side here, I'm going to assume that it was a population actually. Okay. So if this was a population, most of this looks very similar, except I'm dealing with mean, mu, not mean x bar. Remember that they are the exact same. So the only difference is which type of data set you're dealing with. So it's still 5. So when I subtract and found my deviations, they ended up being the same. When I square them, it ends up being exactly the same. So there's no difference there. The difference comes in when you actually calculate, because we have a slightly different formula. So population variance, remember that is sigma squared. Add them all up. Divide by how many there are. Okay, I get 3.6. So sigma squared, my population variance is 3.6. Okay, so the type of data matters on this one big time, because not only is the variable changing, the formula is now changing as well. Okay, and standard deviation, that should be a familiar thing. The standard deviation is the positive square root of the variance. Okay, so we have the sample standard deviation, and we have a separate variable for population standard deviation. Okay, so S is sample standard deviation as the square root of S squared, very simple formula. Population standard deviation, that is sigma, and that is the square root of sigma squared. So notice we take our variance and we square root it. Okay, so if I'm dealing with a sample, so we found our sample variance to be 4.5, that's what we said. So S is the square root of 4.5. Okay, so that would be 2.1. If instead we were dealing with a population value, so our population data had a variance of 3.6. You know, remember I'm using the same data, but I'm assuming one is sample, one is population. Understand that slightly different, just based on which type of data. So our population standard deviation is the square root of 3.6, which is 1.9. Okay. So there we have it. That is our basically 4 measures of dispersion. We have range, mean absolute deviation, variance, and standard deviation, where variance and standard deviation are strongly related. Okay, so we'll do a couple examples here. So find the 4 things, assuming population data. So be careful about that. Pay attention which type of data. Okay, the first 2, it actually doesn't matter. So in this one, the range is the high minus the low. So 12 minus 2, which is 10. High minus low. The mean absolute deviation, so you're going to want to set up tables and understand how to set up tables. Remember, it's population, so I'm going to use the correct variables here. Okay, so 2, 4, 5, 7, 12. Okay, I need to find my mean. So up here, I'm going to do mu equals 2 plus 4 plus 5 plus 7 plus 12 divided by 5. Add them all up and divide by how many there are. So 6, 11, 18, 30 divided by 5 is 6. Okay, so I need that to find this part. So I need to do the data point minus the mean now. So I get negative 4, negative 2, negative 1, 1, and 6. Always check. This should always add up to 0. So that middle column here needs to add up to 0. And it does. If you add them up, you'd get 0. Okay, then we take the absolute values of each one. Okay, and then we add those up. Divide by how many there are. So my mean absolute deviation is 2.8. Okay, notice there's a lot of calculation here. You need to know how to go through all the steps. Be careful of them. Variance, very similar. But now instead of absolute value, we are squaring those values. So 2, 4, 5, 7, 12. Subtract the mean. Make sure they add up to 0. They do. Now square each one. Okay, so my variance, I add them up. Remember, you have to be careful here. Which variance are we looking at? The same, it's population, sigma squared. So sigma squared, if I add them all up, divide by how many there are, is 11.6. And finally, my standard deviation, sigma, because it's population, is the square root of variance. So you take the square root, and you get 3.4. Okay, last one. So we have a few more data points this time, and we have a sample this time. That's important. Okay, so x bar, my sample mean, I'll find that real quick. Okay, it doesn't matter for the mean, which type it is. Add them up, divide by how many there are. So I add all those up, and I get 13 when I divide by 6. Okay, range. Biggest one minus smallest one, which is 15. That's my range. Mean absolute deviation. So we have x minus x bar, absolute value of x minus x bar. Writing really small so I can fit all of it. Okay, so I'll subtract. I get negative 8, negative 4, negative 1, 2, 4, 7. Check. Do they add up to 0? They do. Take the absolute value. Okay, and then my mean absolute deviation, doesn't matter which type, add them all up, divide by how many there are. Okay, so my mean absolute deviation, we add them up and divide by 6, you get 4.5. Now my variance starts off exactly the same, but then I'm going to square each one. So 5, 9, 12, 15, 17, 20. Okay, get my deviations, negative 8, negative 4, negative 1, 2, 4, 7. Square them, 64, 16, 1, 4, 16, 49. Okay, this time it matters, so s squared, my sample variance, I add them all up, divide by how many there are, minus 1. Okay, so I have 6 minus 1. So we'd add them up, divide by 5, and we get 31. That's my sample variance. My standard deviation is the square root of variance. S is my sample standard deviation. So I get 5.6. So you got to be able to pick out the correct variable based on the correct thing. Okay? If you can pick the correct variable, you have the correct formula. So make sure you understand that. Okay, so make sure you write your 3-sentence summary.